Hello and welcome to episode 18 of Chemistry in 15 Minutes or Less. My name is Audra and this review lesson is on Chapter 22, Part 2, Hydrocarbons. Now hydrocarbons, at their basics, are just chains of carbons and hydrogens. Now, there are 5 main subclasses of hydrocarbons. Alkanes, alkenes, alkynes, cycloalkanes, and aromatic compounds. Now, alkanes with the ANE ending are carbon-to-carbon single bonds. Alkenes with the ENES ending are carbon-to-carbon double bonds. Alkynes with the YNES are carbon-to-carbon triple bonds. Cycloalkanes, as you can see, the prefix is different. It's carbon-to-carbon single bonds, but in a ring structure. And aromatic compounds are based on what's called the benzene ring. Now we will talk about all of these, starting with the alkanes. Now, as I said, these have the AN ending in this case. They are saturated. They are carbon and hydrogen with only single bonds, and are also nonpolar. Some properties include they are used in the synthesis of organic compounds and can be fuels or sources of combustion. We'll talk about methane and propane in just a second. These have the foundation of naming all other compounds, hydrocarbons we're going to talk about, using something called the IUPAC naming system. And the naming is based on a system of prefixes and side groups and suffixes. Now the table you use for this is you have the number of carbon atoms, give you a prefix, or if it's a side group, the side group name. Now, the only ones that are important are 1 through 4, because 5 plus become the hydrate prefixes. So 1, the prefix would be meth, and to write it as a side group, it would be a methyl group. 2 is F, or an ethyl group. 3 is prop, or a propyl group. And 4 is bute, or a butyl group. These are important to memorize. If you don't know what they mean, you are going to have a hard time with a lot of the organic compounds we do in class. Because this is going to come back to haunt you with the alkenes, alkynes, cycloalkanes, and sometimes even in the side groups with aromatic compounds. So. Now, we're going to go through a couple of quick examples of these. We're going to do more examples of these than the others because these are sometimes harder to follow. So, for alkane, you could have, with 1 carbon in the chain, methane. Because you see, you take your prefix and the ending from the type of hydrocarbon that it is. If you have a 2 carbon chain, that's when you start to get into ethane. Same thing. Prefix, ending. 3 would be 1, 2, 3. My hydrogens are getting worse the longer I draw them. This would be something called propane, which might sound familiar. Use it on the grill, which is why we talked about with fuels and a source of combustion. Or if you have a 4 carbon chain, you have something called butane. Now, once you get up past butane, I don't know why I erased the title, you get into isomers. Really, once you get up to butane. We're just going to quickly go over how to name these so that way we can quickly gloss over the other sections. But let's start with something called pentane, which is a 5-carbon chain saturated with hydrogens. It's an alkane, all single bonds. Now there are a couple of different isomers you can do, because there have to be 5 carbons total, not necessarily 5 in a chain for it to be an isomer. Now if you have a 4-carbon chain like this, and have 1 extra carbon you can put somewhere on the chain, there's a couple of different places you can put it. If you put it here, it would still be pentane, because you can bend this and search for your rotation to go out here, and it's the same thing. So then instead of that, you can put it here, which basically gives you 4 and then a side group. Now this side group might look slightly familiar with 1 carbon. It's a methyl group, which means to name this, it would be, you find the parent chain, which in this one is 4, and then there is a methyl group, so it would be methyl butane. Butane? Yeah, methyl butane. But see, also with this one, there is one other possible one you could do where you have a chain of 3 main carbons, and then put the 2 groups here, which would be dimethyl. Since there are 2 methyl groups, you use prefixes here in front of the side groups to tell how many. Dimethyl propane, because the parent group has 3. Now that is the basics of all of the other naming, using the prefixes for the side groups, the names for the main side groups you'll use other than functional groups, which we'll talk about in the next video, which will take us to the next on our list of subclasses, the alkenes. Now, alkenes, in and of themselves, they are unsaturated. They have carbon to hydrogen with at least 1 double bond. They are also nonpolar, and some properties include their usage in forming polymers and are used in detergents. Now they are similar to alkanes in the way that you name them, except for the fact that they have the ENE ending. So for example, if you have this molecule right here, it would be eth for your prefix, because there are 2 carbons, but since there is a double bond, ethene. The only thing that there is to talk about is you have to add certain prefixes to your suffix in order to tell you the number of double bonds, and position numbers once you get into longer chains of alkenes. So let's just clear a little bit of space, and let's say we have this molecule right here. Now that is with the full number of hydrogens, and as you can see it's unsaturated because there could potentially be 2 more hydrogens here in this position. Now, there's only 1 double bond, and there are 1, 2, 3, 4, 5 carbons, which means it is a pentene molecule. Now since there's only 1, you don't have to add anything in here, but you will need to add a position number. And basically the way you do position numbers is you number the carbons from one end to the other end, and see which one gives you the smallest number. So if we're going from this side, it would be 2 pentene, but if you're going from this side, it would be 3 pentene, because you do whatever carbon the bond starts on. So you don't have to say 3 going from this angle or 4 going from this angle, you say 2 or 3. This would be 2 pentene because it gives you the smallest number, and it doesn't matter which way you draw it, it's still going to be the same molecule, just inverted in space. The endings to know for if there's more than 1 double bond are things like, you would have your A, diene, triene, and so forth, using the same hydrate prefixes that we have been using for a couple of chapters. Now the alkynes are going to be very, very fast. They are unsaturated, they are CNH but with 1 or more triple bond. They are nonpolar, and some properties include their use in polymerization because they have a multiple bond, and can be used to ripen fruit. They are more similar to alkanes, but they have the Y and E in the ending. You have to put position numbers for triple bonds and modify the suffix to tell you how many, but other than that, the only difference from these and the alkenes is the Y instead of the E. And we're going to briefly go over cycloalkanes. Now, cycloalkanes are saturated because they are an alkane, which means they have only single bonds. They are found in some types of petroleum sources, and they are labeled the same as alkanes with side groups, prefixes, suffixes, but with the cyclo prefix after your side groups. And they'll tend to be in a structure that looks something like this, but with varying numbers of carbons because they are a ringed structure, hence the cyclo prefix. And the last thing to briefly go over are aromatic compounds. Now, as we talked about, the aromatic compounds are, in essence, unsaturated because they do have some double bonds. They are nonpolar, and they are based on a 6-member ring with delocalized electrons, which you might recall we talked about briefly when we went over resonance structures in the Lewis-Downs structures. So in this badly drawn version of benzene, we have a 6-member ring. And basically, the double bonds would be here. They'd be on every other. But instead of having to draw, both of them, where you have the position numbers for the double bonds slightly different, you don't have to do that at all. In fact, you're supposed to draw benzene like this, where you draw single bonds all the way around, and then you draw this little circle in the middle to show that the electrons are delocalized and are spread across all of the bonds instead of having to draw a resonance structure every time you want to have benzene. The parent chain for this will always be benzene, so whatever side groups you could have methylbenzene, dimethylbenzene, and so forth down the line. They are used as starters for polymers and are also used in dyes, scents, detergents, explosives, and types of drugs. As you can see, benzene and the aromatic compounds have a lot of different uses. But the other thing we did talk about in this is there are some forms of benzene that have more common names, like methylbenzene, which is called toluene, and dimethylbenzene, which is called xylene. You don't have to memorize these like you have to memorize the other ones, but we did mention them at this point because you'll notice that sometimes different types of hydrocarbon chains or compounds will have different names than what they actually are. Like, one of the most common examples is water, H2O. You don't call it dihydrogen monoxide, you call it water. And with that's a lot of information, I know. That should conclude episode 18 of Chemistry in 15 minutes or less. Feel free to leave questions or suggestions in the comments below, and be sure to follow the in-video links, check out the playlist, or head over to my channel for more videos on chemistry review. As always, I hope this was helpful, and have a great day.